Okay, we are recording again. So this is the next section of today's class, where we focus more on the actual instruments or the software that allows us to compose. When I say instruments, it's a combination of the actual sound making modules, but also the way to organize them. One of the questions, of course, what is a musical software? It's a notation pad. It's your pen and paper and musical stave. Is this the instrument? Is this your orchestra? So one thing to keep in mind is that given technology and everything is done in one box, and these questions a little bit become obsolete. You compose for the instrument, and the way you can compose and the way you trigger things becomes so closely combined, and now you're the producer, you're the composer, you're the performer. It used to be that before the age of orchestras and kind of separation of the composer from the performer, from whatever the conductor and maybe the producer later on, it used to be that a musician came with his instrument and he would be the one who composes this and he would be the one who performs. And then it kind of, for a lot of reasons, maybe industrial revolution way of thinking, the zeitgeist, things became very specialized. But today, since one man can be doing everything, also these musical notions kind of became mixed. So if we think about one of the early software that allowed people to go and a little bit think more musically than really triggering computer codes that generate sounds. And this is how it was done before the tracker. You would actually write software with specific instructions. Here you had this machine or this piece of software that starting with Amiga in 1987, that allowed you basically to put multiple tracks. Each one is an instruction for a note being played, and it would kind of run through these lines of code and trigger sounds. And this has a very specific type of sound. I don't want to take too much time on playing these, but just going to demonstrate how it runs through. So once you start running these, and I'm not sure if I actually, when I was sharing, if I included the sound from the computer. So let me kind of quickly make sure. Yeah, I was sharing sound. So you could hear this. You can also see the waveforms. It's a little bit like the video from the previous lecture, where you could kind of combine very basic waveforms to create the Legend of Zelda theme. Here, you have many more of them. They can move and get organized in much more elaborate and specific ways. So this is kind of a tracker. We will not be using tracker, although there are a lot of trackers available now for download. We actually jumped into using so-called sequencer, but people started with the tracker and got inspired by them, like Ernst Eisen and the Infected Mushroom. They composed most of them, the Duvdev and Shidapo, the Infected Mushroom duo, did a lot of their trance music on Impulse Tracker. And you would say that their unique style is actually very much linked to the abilities or the type of musical expression that the tracker is built to represent. So we moved away really from early game music to something which is very much a mainstream. So you don't have to do psychedelic techno with trackers, but somehow it is a very powerful tool that many composers use, and the audience enjoy them. So I'll just kind of quickly read the quote from them, from Duvdev and Shidapu, and they say about their Goa Trans track that you needed no studio, no equipment, no monitors, just a PC and an impulse tracker. So really before the day of the PCs that became, with Windows and GUIs and stuff, you would code in these little tracker software, but you started having basically your laptop studio. Now, the next big change, or actually the milestone that moved us from the structure of tracker or sequencer. So I didn't talk too much about sequencer because we had a lecture about LMMS, and this is still that you'll be using, so you'll get really to know pretty well the logic of sequencer. Sequencer is kind of a tracker, but really reworked in a way that is much more flexible and has now multiple instruments and allows you to do more of a traditional musical thinking, but you can also do stuff which is very much like a tracker in the looping fashion. So skipping the sequencer, I want to mention the iMuse. So iMuse is a music games engine which was created and patented by LucasArts. And it is considered as the beginning of the concept of adaptive music. When we first looked at adaptive music examples from much later games, you could see that there is really a need to be able to switch between musical scenes because of the dynamics of the game. But the software or the game developers try to make this, a seamless experience. It would be something that would be natural to the musician or the person who plays the game, kind of to feel that this is how things should have happened. There's no abrupt change. There are no like cuts in the sound. And when you move from one situation to another situation, the music follows you as if it knew that this is how things should happen. Well, with the previous software, with the tracker, it's very hard to do because each track or each of the compositions in the tracker represents one musical scene. And then when you move from one to another one, you have basically to turn one off, start the next one. But besides the technical difficulty, you have a musical problem. You don't have a transition. So iMuse wanted to break out of the loop-based composition of the tracker, and it created a system, a patented system that was implemented for LeChuck'S Revenge. The MUNKEY Island 2 is kind of this classical example where music changes based on location and character. Now, why I'm bringing this? Because the idea that we need to compose music for each scene is kind of an underlying logic of this class. We will be composing scenes, music for 3 scenes, and the final project will be really about composing a transition or making some kind of a way to move smoothly between the scenes. So if you check out this game, okay, I would to just a couple of things. One is how music goes and turns when the main hero, right? We have Largo Legrand, the pirate moves around between different ships and goes to this how do you call it, port, right? And then he visits all kinds of places. He also moves outside. He goes out there to explore the island and swims in a boat. Later on, he meets his parents and some skeletons. I mean, there are a lot of stuff here, and each one has its own really fun musical technique used. But without analyzing everything, just notice if there are segments where music changes based on the location or the atmosphere, and what happens when it goes out and comes back to the same scene, how music kind of returns to the same type of music. Very much like the first examples we discussed about adaptive music, but this is kind of the historical classical example. And just an anecdote about this was that they did such a good work in terms of designing a system that made the music flow so seamlessly that, at least according to the musicians and the computer programmers who developed the software, part of the disappointment was that it was so seamless that people didn't even appreciate the fact that there was so much work done to make the music seamless. It's almost like you had humans who would sit and basically improvise to the film and be intelligent enough to make these nice transitions. But to make a computer do this was a tremendous effort. So check out the game, and I'll meet you in the next section or the next page.